How's everyone doing this morning? My name is Matt Perenich, and today we're going to be talking about additive manufacturing in wind turbines. So with that, let's get started. So today we're going to go through an overview of wind turbines, an overview of additive manufacturing in wind energy, applications of additive manufacturing in wind energy, the future of additive manufacturing in wind energy, and then questions. Wind energy is renewable, reliable, and sustainable. It's a type of renewable energy that converts wind velocity from turbine blades into electricity without any CO2 emissions. Blades can be up to 60 meters in length, and the total height of a turbine can be as high as skyscrapers. There's been tremendous growth in past years, and the United States expects to use 35% of their energy from wind by 2050. And with this demand getting higher and their larger size, manufacturing is a challenge. But the need for good, efficient manufacturing innovation is important. So, quick little introduction on how wind turbines work here. So first we have the wind blowing over the blades, and because the way the blades are shaped, it causes the blades to spin about a hub in the center there. So those blades actually have airfoils embedded into them, and they actually create a lift force when an air velocity goes over them. And that hub is connected to a planetary gearbox, and that increases the speed of rotation 100-fold to the generator there to the right next. And that generator then converts the mechanical engineering energy into electrical energy and sends it down the turbine through the cables till finally a step-up transformer sends the electricity out accordingly. Can completely revolutionize wind energy. This picture on the left shows operators working on a turbine blade hours and hours. And this picture on the right shows a turbine base being mounted in the ground by a large crane. So you can see that these are still 20th century innovations and manufacturing techniques. Industry, we have some additive manufacturing techniques already. Molds for turbine blades, main body covers or nacelle covers, magnets, heat exchangers, and repairs. And the types of AM processes used are big area additive manufacturing, or BAAM, electron beam, and fused deposition modeling. These pictures here both demonstrate applications of additive manufacturing in turbine blade molds. So these are both on the smaller scale, but the picture on the left is actually still considered a big area additive manufacturing type of extrusion-based process. And a subtractive post-processing will happen later to it to finalize the mold. And on the right-hand side, we have another mold by the Oak Ridge National Laboratory. A little bit larger scale of turbine blade molds that need to be innovated by additive manufacturing are these larger ones, which are on the 30 and 60 meter scale, which is quite large. But these molds are also made by additive manufacturing, and you can even see a process of this all the way on the right. In that right-hand picture, we have big area additive manufacturing, or BAAM is the type of additive manufacturing used there. And there's actually also applications not just from BAAM, but also FDM and EBM, which we have already learned in this class, seen on the left and the right-hand side here. The left being a VAWT Darius wind turbine, and the right being a traditional manufactured smaller wind turbine. Application, the companies on the right hand side of the screen got together and created this wind turbine base with this BAAM technology, the extrusion base for concrete, and they started the base of a wind turbine, the rest to be manufactured on top of it. And this machine is supposed to be implemented on the field so that the base would actually never have to move and the machine can just be disassembled afterwards. Here's a couple more applications of the main body being 3D printed to cut down on cost, time, weight, and finally, future, additive manufacturing technologies could enable on-site manufacturing of turbine parts as well as production of site-optimized components that are tailored to the unique wind and grid resources of a given location. And these advancements in macro 3D printing could change everything. And we start seeing that in these pictures here on this slide that show the actual additive manufacturing of the blade itself, the turbine blade itself. Any questions?